LeetCode question number 1110, delete node and return price. This is medium question. Let's get into it. Given the root of a binary tree, each node in a tree has a distinct value. After deleting one node with a value into delete, we are left with a forest, a disjoint union of trees. Return the root of the trees in the remaining forest. You may return the result in any order. So sequences doesn't matter. Okay, let's check the example 1. Now root is 1, 2, 3, 4, 5, 6, 7, and then to delete is 3. So delete this one and then delete this one. So left is this one, remaining this one, and then this one and this one. So 1, 2, 4, 1, 2, 4. This is the right night children, and then next is 6 here, 7 here. Okay, how we gonna do? Yeah, that's right. Today I'm gonna use the DFS to traverse every node one by one, and I would like to use the bottom-up approach. So checking is bottom-up first. So first, I would like to check for first. 4 is to delete, no. So 3, no. 5, yes. So I delete 5. So 2, no. 1, no. So, and then this one 6, no. 7, no. 3, yes. So at this time, when current node value is into delete, to delete is this one. I will delete this one and then return none, and then put the left and right child to the output. And then finally I will check this one. This one is in the to delete. I did not put into output, but that is not in to delete. I put it out too. Okay, let's implement code. So first we need to DFS is node, and then base case is if not node is I return, and I will the recursion first to the bottom up approach. That is the checking the bottom first. So node left is DFS node left, and then node right is DFS node right. So first, when root is here, right, and then I put here, and then first this is not null, yes, and then left node, and then node left, and then recursion again. Now we are here, right, and then going here again. So we have to start to check here. Does this make sense? And then next is we check the right. Then right is here. Right is 5 here. Okay. 5 is here, right? So okay. Then let me check next. Not the value in to delete, and at this time I will check if node left is exist. I will for append node left, and if node right is exist, for append node right. And then I will return node is what? Okay, now that is the to delete. So in this 3, okay, let's say we are here 3, and then 3 is the to delete here, right? So in this case, this one is cute, and then first the node left is exist, yes, 6 exists, 6 to the output to here, 6 here, and then 7 also exists, yes, that's right, so 7 also put here, and then itself, okay, return, and then this one will receive. At this time, this one must be none. Means in this, okay, let's just change view of the node 1, and this time right node is none, that means we delete it, right? So 1 to null. Null is here, null is none, this one. And then otherwise just return node. Okay. I would like talking about this one. Can you calculate this one time complexity is big O n, right? Because this is a list. Can you make it to constant? That's right. How we do? Yeah, just we change the list to set, right? So first I will make to delete set, and then that is set to delete to make it 01 to 10. So I will use this one, and okay, and then we need to output. Then I will put if before that, if not root is empty, I return empty pressed, and otherwise if root value not in to delete that, I needed to append output to root, right? And then dfs root, and then while did I append if that is valid, it going to output, right? So I return output. Invalid. Which one is invalid one? Oh, this one is why invalid. In delete set. Wow, what is that? Set to delete. Okay, looks good. Let's submit. Okay, let's think the time complexity. Time complexity, while iteration, we touch the node just one by one, right? From bottom front, one by one. So time complexity is, I think, the linear time. And then space complexity is the head of the tree, because we use a system stack of the recursion. And the worst case is if the node is left screwed while the right screwed. The 80 is the same of number of nodes, so we can say worst case it take linear time with linear space. Thank you.